I'm Andrew Whiteoak. I'm a PhD student at Liverpool John Moores, and I'm going to tell you a little bit about my research. A model species is an animal whose behaviour or physiology we observe in order to draw inferences about other animals or ourselves. This works really well in ecology, where we can monitor the diversity of small bugs to assess the health of an ecosystem, but it's a little more difficult when we want to find out more about the heart. At the moment, our only options are either growing up cells in vitro, that's not exactly a heart, that's just cells, or using an animal such as a mouse or a frog. And while we could argue till we're blue in the face that humans are worth it, that heart disease is the #1 killer in the UK, that 30% of all deaths globally are from heart disease, this still doesn't take away the ethical issue that other animals die to help us in our attempts to resolve this. Well, what if there is an animal that didn't have to die, whose heart we could monitor, that we could see easily without making a single cut? Daphnia are a type of crustacean. That's a water animal related to crabs. They're completely see-through. You can see their guts, you can see their babies forming in their wombs, and you can see their hearts. Okay, so there's a small technical issue there, namely they're small, they're microscopic. They're about 1 millimetre in body length, and the heart is 1/100th of that. So you need a really good microscope. And then there's the heart beating 5 times faster than our own. So you need a high-speed camera equipment with software to slow it down afterwards. But unlike other invertebrates, their heart has something we share. It's myogenic. That means it beats all by itself without input from the brain. And that means that, as with mammals, we could observe that heart's response to stimuli and build up a comparison to our own responses. This body of data could allow us to adopt Daphnia as a model for heart therapeutics that could then be used on humans. That way, we'd have an animal who we don't have to cut nor kill, that grows as bugs do by the 100, which could tell us something about cardiovascular therapy. It might well help reduce the threat of heart disease, and it might even save some lives.